Thank you, everybody, and thank you for coming to this session of Passwords Anonymous. My name is Alex, and I'm addicted to passwords. My problem started in 1996 when I logged into a free serve account. From there, 1 password became 5, 5 became 10, 10 became 100. I might get through 100 bits of entropy in a day. But with your help, I hope I can overcome this problem one day at a time. Thank you. So, a quick recap of things I'm sure we are all aware. Passwords suck. They are terrible. They are terrible for users. Users reuse them. We write them down. We forget them. We type them into the wrong website and a Nigerian prince gets hold of them. And after all that, we still forget the damn things and need them reset on a regular occasion. It's not just users that passwords suck for, they suck for servers. Servers have to give you ridiculous rules to try and encourage you not to use password 1. For those of you wondering, there is such a thing as a lowercase number. Unicode has some weird edge cases. See the talk on hypothesis. Now, 2 quenziums is about a month. That's the standard rate. Of course, your password is securely stored. It will never be leaked, and if it's leaked, don't worry, it won't be brute forced. So, if passwords are, and they're breeding, we get more and more passwords. I'm sure there are people in here that have 3-digit count passwords in a password manager. Is there anybody who would like to raise their hand and admit to their problem? Oh, wow. OK. It's getting to that point. And we need password managers because for a password to be useful, for it to have any hope of protecting the thing it needs to be complex. But if it's that complex, you can't remember it. If it's a password you can remember, it's not worth remembering because it's useless. And it's not just computers that are asking for passwords now. Well, it is computers that are asking for passwords. It's just that everything's becoming a computer. So now your games console needs a password. Your phone needs a password. Your phone needs lots of passwords. Thermostats need passwords. Why the hell do thermostats need passwords? The other problem with the password is I'm in a long tradition of predicting the end of the password. The earliest account I could find of this was 2004, but I am certain there are cases going back to the 70s, the 80s, and the 90s. The trouble is that even though passwords are terrible, they're a little bit less terrible than all the other things that we've tried. So we keep going back to them as like the least common denominator. Just to give you a very whistle-stop tour of different things that people have tried to replace passwords, you've got federated logins, which are things like login with Facebook, login with Twitter. They don't need to be reissued. You don't need to ask them to email you a new password. Well, Facebook has to worry about that, but if you're the website using login as Facebook, somebody else's problem. Trouble is that every time you use it, Facebook knows that you logged into whatever website it is. So you might not want to use that for every website you visit. And it only works when you're on the web. It doesn't work for thermostats. Hardware tokens. So I'm sure everybody has had one of these from their bank and or something for their corporate network to log in with a VPN, little 6-digit thing, changes every minute. They are much more secure than passwords. They're much harder to clone. They're much harder to phish. But they require training. They're not that familiar. They're proprietary. They are expensive to implement. It costs a lot of money to send these out via the post. So they're hard to deploy and they're hard to reissue. You've got phones and apps, Google Authenticator for Android, a few others for iPhones and Android. They've become a lot more popular since smartphones have taken off. They suffer some of the problems of hardware tokens. They're a bit more standardized, they're a bit less proprietary, but they're still a bit unfamiliar to people. You've got biometrics, which is the Hollywood solution. The advantage of it being the Hollywood solution is it's quite familiar. Everybody's seen somebody use voice print or retina or fingerprints. The trouble is that there's not many places you can use them. There's a few corporate laptops have a fingerprint reader. I don't think I've ever seen a retina reader. And they are impossible to reissue. If somebody gets hold of my password, I can choose a new password. If somebody gets hold of my fingerprint, well, I've got one more chance. So as a result, they're almost nowhere. I do apologize. This is the long version of this talk, so I'm just about to flick through a few. This should have been the short version of the talk, so bear with me while I flip through superfluous slides. Right. So, that is a nice tip, by the way. Please don't disable password managers. Be a nice developer, be a nice system admin. Password managers are more secure than people trying to remember password 1. So, what's the answer? Well, we're stuck with passwords for a while. Maybe we can make them a bit easier by making two-factor authentication a bit less of a pain in the ass. There is an alliance trying to do this called the FIDO Alliance. It stands for Fast Identity Online. It's an industry consortium. Backers include Google, Microsoft, I think Facebook are a member, ARM, PayPal, all the people that have to worry about security because, worry about passwords because when they go wrong, money is involved, lots of it. The idea behind the FIDO Alliance is to make open specifications for strong authentication, to give certification testing for companies that have products and want that, and to base it around public key cryptography so that everybody writing servers doesn't have to have sensitive information on the server anymore. If you go to these APIs, all that's on your server is a public key. And if, God forbid, your server gets hacked and your database gets leaked, the most sensitive information in there will now be the email address. There won't be if you choose to go with the variant without passwords, all you have to store in your database is a public key. It is designed to standardize all these various hardware tokens, fingerprint readers, secret decoder rings. Fuck. Oh! Sorry. Please bleep that.
My precious.
You, as the developer, get a single API, and we, as the users, get to choose whether our authentication token is a little USB thing that we can only use with our laptop, or an app running on our phone combined with a fingerprint reader on our phone. FIDO Alliance, think of them like the Wi-Fi Alliance people, but for authentication. They're putting a brand on it. They're making it standard. They're doing interoperability tests, making it a feature that you can sell and that you can just slot into, and hopefully it works. And all of those different authentication methods are behind a single browser API or a single SDK if you're writing an app, and there are only 2 or 3 functions to worry about. So there are 2 standards from the FIDO Alliance. The first is UAF, Universal Authentication Factor. What? Oh, well, that should be more appearing there. The second is U2F, Universal Second Factor. That is for replacing your 2-factor authentication. You'd still have a password. This is where I'd pull the bait and switch. I'm afraid the only one that's got a widespread adoption so far is U2F. So you are stuck with passwords for a bit longer. UAF, the standard is there. You can use it on certain smartphones, but not in the browser yet, I'm afraid. And they are both fairly similar standards. Once you've implemented one, you've done most of the work for implementing the other. The idea is that you have an authenticator device, might be your phone, as the user, as the server to register your user with U2F. You start with a user that you already have a username and a password for them, so they're logged in, first step, and you want to enroll them in 2-factor authentication. You, on the server, generate a challenge, which is just some random data, and give the user some nice URI, nice user interface to say, click here to enable 2-factor authentication. That generates the challenge and sends it to the client browser. The client browser does all the underlying low-level stuff to discover what devices the user has, and once it's done that, it sends the challenge to the devices. The device goes bingly, bingly, beep. BobsWarehouseWidgets.com would like to enable 2-factor authentication. Press here to confirm. So that is proving that that there is a human here. When that happens, the authenticated device, my phone, generates a private key. Private key is one that never leaves the device and should be stored in a secure element. Private key is used to sign the challenge. That data is then sent back from my authenticator through the laptop, through the browser, to the server. The server gets a signed response, a key handle to refer to this in the future, and a public key. And that's all they have to store. Just check the challenges matches what was sent and matches a database of known authenticated devices if you want to do that sort of sanity check. And you're done. You're registered. No pins if you don't want to. You can use an you can use fingerprint biometrics. You can use a USB token with a little touch thing. Same API, same traffic. The only difference is that the browser needs to know how to talk USB versus Bluetooth. So now we're registered. It's a few days later, and I want to submit a purchase order for £3 million of Type X widgets. That's a big order. Are we sure it's me and not a Nigerian prince? I'm logged in with the password. Still logged in from my session yesterday, but I've done this big order. Bob's Widgets would like to make absolutely sure it's me to comply with his insurance and security things. So at any time, he can ask for extra confirmation by asking me to authenticate with the second factor. Very similar to the registration, generate a challenge, send it to the browser. Browser finds out that I've got my authenticator with me. My authenticator goes bingly beep. I press it with fingerprint or just activate it to say there's a human here. That uses the private key it generated, signs the challenge. The response goes back to Bob's servers. Bob's server has my public key, checks the signature. If all is good, I've just bought £3 million type X widgets, or transferred £6,000 to somebody else from my bank account. That's nice. Let's get into some nitty-gritty details. You can do this in Python. There are open source libraries. Thanks to the nice people at Yubico, a Swedish company that makes these USB authenticators. There are libraries for other languages as well, if you need to. This is the server generating a registration challenge. So we have u2f.startRegister. That's provided for us. That gives us a challenge, which is just a small snippet of JSON. We send that to the browser however we want. Could be in a form field, could be in an AJAX request. Doesn't matter. The browser gets it. The browser provides this function u2f.register. We provide the challenge from the server and a callback for what to do when the user has touched their device to confirm that they want to register. In this case, it just stringifies its JSON and submits an HTML form. But again, you could submit it via AJAX, carrier pigeon, whatever you want. Again, it's JSON. So we've got our challenge response on the server. We call u2f.completeRegister. That does all the cryptography for us, raises an exception if there's anything wrong. Otherwise, it gives us a registration object and an attestation object. The attestation is how you check that, if you wanted to, it's actually a Samsung Galaxy Note 2 that was doing it and not something somebody inserted in software on the browser. You can check that if you want. You don't have to. Once you've done that, you save the registration, and then that is what the response from the browser looks like. Authentication, almost identical. It's just this time we've already registered, so we've got a public key to check against. Generate a challenge. Challenge looks like that. Key handle is what was sent to us earlier. That's how we refer to this device. That goes into the browser. We call u2f.sign in JavaScript in the browser. Send that back to the server. Server, again, checks the signature. If there's an exception, we know about it. The other additional protection we have here is that in the device there is a counter. The devices are meant to be tamper-resistant, so very hard to get the private key out. But if an adversary manages to clone a device, each authenticated device has a counter. So if you see the counter ever go backwards, you know a device has been cloned and you can take appropriate action. Appropriate action will depend on your risk model. Now for a demo. Bear with me 1 second while I jostle screens around. Actually, I can just open it in there. You will notice that I am doing this over HTTPS. That is a requirement for FIDO standards and U2F. You will get an error if you try and do anything. Oh, what have I done wrong? Oh, it's on port. Sorry, wrong port. 8001 is my slides. There we go. Okay, so this is a Django application called Django two-factor auth. It's been around a while. You can already use it with SMS, telephone, YubiKeys, and Google Authenticator type things. We've already set up with a user, and we're going to log in that user. Okay, we're logged in, but we don't have two-factor authentication enabled. So we could see, for instance, we're logged in as an admin, so we can see the active sessions. But we have here a secret page which is protected by two-factor authentication. You must have two-factor authentication enabled to view this page, and you must have verified it. So it's offering to enable two-factor authentication. This gives us a number of options. This is modeled after Google's two-factor authentication. It is wise, if you're implementing two-factor as a server administrator or a developer, to give the user multiple options and to let them choose more than one, because you can be guaranteed that I won't have, even though this is tiny, I won't have it always with me, or if I choose phone, I won't always have a signal. So I'm going to choose U2F. Behind the scenes, it's generated a challenge, and that's in a hidden field on the form. I'm going to plug in the device. I'm sorry you can't see this, but I promise you that there is a little flashing green light on the device telling me it's activated and that I should touch it. I'll do so. You might have seen some text flash up in there that filled in the box with the JSON and automatically submitted the form. I'm now two-factor enabled. Just for completeness, I'll add my phone number. And because this is a demo, actually total garbage works. Text message. So this is purely as a backup. 746,819, yes. A wonderful number. Great, so now I have two-factor authentication enabled. I will log out, log in, save my password, great. Now it's asking me to do two-factor authentication. Plug in the device. It flashes. I touch the device. You briefly see the challenge response there. And I'm logged in. I'm two-factor verified. And I can now view the secret page, which was previously protected. So, sorry to rush through the demo like that. But if any of you would like to use this yourself, I'm afraid it's still under heavy development. The plugin that adds U2F support to Django two-factor authentication is in a particular branch on my GitHub account. So is the integration with Django two-factor auth. If you'd like to use two-factor auth not involving U2F yet, two-factor auth is a mature app and ready to use today. Just finally, I do have some bad news. Mozilla are working on it. Slight ray of sunshine. Edge browser and Windows 10 do have U2F support. I haven't played with it yet, I'm afraid, so I can't say exactly how well it works. It will be happening in other browsers. There is a lot of industry support behind this. Watch this space in the coming months. The other piece of bad news, I'm afraid there are phones that support U2F over Bluetooth, and there are specifications for U2F over Bluetooth and NSC. Unfortunately, Chrome, the only browser that supports it, only supports it over USB so far. That will be changing. Spec came out in July. There is experimental generic Bluetooth support in Chrome in the developer version at the moment, so give it a few months. Any of you that have a Samsung S5 or an S6 or a Note 4, you already have UAF and U2F support in your phone. Anybody getting an Android M phone in the next few months with fingerprint support, that will probably be baked into the Android operating system by that point. There is links for some more information. And credits for the photos that I've used today. The slides for this I will be tweeting, but if you visit moriarty.github.io/passwordspane, they should all be there. Thank you very much.
Thank you very much, Alex. I enjoyed that. We have, given that it's only 1 minute to 12, and 12 o'clock is lunchtime, enough time for perhaps 2 or 3 shortish questions. I'll start at the front and work backwards.
Yeah.
Ah. Okay, let's limit to 2 minutes, and then jobs fair.
Thank you very much, Alex. What is the process if that thing gets... What is the process if that USB thingy gets lost or your phone gets stolen?
So that is the reason that I made a backup method with my phone for SMS. So in that demo, if I log out and log back in again, I can choose either to use the USB dongle with U2F, or I can ask it to send a message to my phone. Now,
what will you do?
It also gives you the option to create a set of static one-time use passwords that you can write down on a bit of paper and keep in your safe deposit box. Or ultimately, you would have to have some sort of email address or help desk system that people could call to ask to get their account reset. And that's as much depth as I can go into now.
Okay, we have time for one very, very short question, very, very quick answer.
Okay.
Thanks for the talk. I was just wondering, how is this sort of usable for older people, you know, the ones which are just about managing to navigate a browser?
I don't know.
Okay, that's it, folks. It's going to be the jobs fair in here. Thank you very much, Alex. Really, really well done.